Good evening, ladies and gentlemen. Tonight we start our unit on parallel and perpendicular lines. So to start off, I suppose we need to know what parallel lines are. Here is the textbook definition. They're coplanar, meaning they lie in the same plane, and they never intersect. When we want to say that two lines are parallel, we can say that this line A is parallel to line B. And instead of writing out the word parallel, we can use the symbol, which are two parallel lines going up and down. If I want to show in a diagram that two lines are parallel, then all I need to do is, well, if I can, there they are, is put two matching arrowheads on my parallel lines. If I wanted to show that two other lines were parallel and not parallel to the first two, then I would use a double set of arrowheads, for example. Very similar to what we do for congruence. Let's see. Okay, and the thing that we need to know for this unit is that parallel lines have the same slope. Now, we were talking about slope and equations of lines for this very reason. What you're going to be asked to do in this unit is to find the slopes of two lines and determine mathematically by the slopes, not just by looking at them, whether or not they're parallel or we'll get to in just a minute perpendicular. So parallel lines, because they run in the same direction, they have to have the same exact slope. Perpendicular lines are coplanar lines that intersect to form right angles. They look something like this. So we have a symbol. We could say A is perpendicular to B using this kind of symbol that looks like two perpendicular lines or lines that intersect in an upside down T. And to show that two lines are perpendicular, we use our right angle symbol in any one of the corners, or angles, I should say. Because if one angle is 90 degrees, then the angle adjacent to it must be 90 degrees because they're supplementary, and the one adjacent to that is 90 degrees, or you can think of these two angles as being vertical angles, so they must be congruent, and this angle must be 90 degrees as well. So it doesn't matter where we put our right angle symbol, we know that all the angles at that common vertex must be 90 degrees if one of them is. Perpendicular lines are a little bit more complex. They have opposite reciprocal slopes. So if we remember back to previous years of math, a reciprocal is a fraction that's flipped upside down. So sometimes I think of a reciprocal as being a refliprocal because, for example, 2/3 and 3/2 would be reciprocals. 1/4 and 4/1 or 4 would be reciprocals. 7/8 and 8/7 are reciprocals. So perpendicular lines have reciprocal slopes, but not only are they reciprocal, they also have opposite signs. So if one slope is positive, the other slope has to be negative. So perpendicular lines, their slopes have to meet two conditions. They have to have opposite signs and be reciprocals of one another. So an example of two reciprocal slopes might be -2 and +1/2. Another example could be 4/5 and -5/4. So write down an example so that you keep it in mind, but it has to fulfill two conditions, be opposite signs and reciprocals of one another. And the last type of lines we're going to talk about today are skew lines. These are non-coplanar lines that never intersect, which is why I gave you a three-dimensional picture. Because they're non-coplanar, you can't draw them on a flat surface like your piece of paper unless you represent it with a three-dimensional figure. So these two lines would be skew because while they do not ever intersect, they're not parallel either. And the only way to achieve that is to have them be non-coplanar. We could also illustrate it in this way. If we have a plane, we have a line that, oh, I can't make it show up, that intersects through the plane. So hold on, let me do this. There we go. If we have a line that intersects through the plane like that, and we have a line that's resting on top of the plane, these would also not ever intersect. And that's it.